Alright, Hosses, welcome back. And before we get to this video, let's just go ahead and recap what we did so far in our program. So right now, what our program does is it sits on the network and it just waits for data to come across. Now, whenever it receives any data, what it does is it takes it and it starts trying to figure out what it is. Now, up to this point, we can figure out the destination, what device it's coming from, where it's going to, the Ethernet protocol, and we also found inside our package another package. So now what we need to do is we need to say, okay, well, what about this payload that we found inside? Let's go ahead and start interpreting that. So this was all the Ethernet frame, the Ethernet data, basically how data from your computer gets to the router, but now we got to unpack the IP packets. This is pretty much the good stuff. So we already took care of a lot of the boring stuff. The IP packets are what we're going to be unpacking now, and I'll give you guys a real quick diagram of this. So basically, the IP packets and IP headers, this is how you connect with another computer on the internet. So not just your router, but it's how you connect to, Facebook server, YouTube, Reddit, whatever. So basically, every computer has an IP address. So whenever we want to talk to Facebook, we need Facebook's IP address, which is already going to be bundled up in here, and we need to send it some other information. What IP address to send, the pictures of my ex-girlfriend back to, which is mine. So we have just the IP version, the header, the length, the source address, destination address, and again, these are IP addresses. So that's what we're going to be doing in this tutorial. Unpacking the IP data, and IP stands for Internet Protocol, basically data that you're going to send across the internet. So again, that's what this is. So let's go ahead and make that right now. And let me add a comment. I'll say unpacks IPv4 packet, and I don't know, that's good for now. So we're of course going to check to make sure that the Ethernet data that we got, whenever we unpacked it, we only want to worry about the internet traffic. I mean, we really aren't worried about anything else like ARP or anything like that right now. So whenever, I don't know, maybe our kids or our friends that are living with us, they go to some website, we're going to start extracting that and seeing what they're up to. So def IPv4 packet. And remember, we're going to be passing in this little bundle of data eventually. All right. So let's go ahead and take a look at what we need to extract. The first thing that we're going to extract is this, which is just the version and the header length. And I'll show you guys how to take this one byte and break it up so you can, see each one individually. Now we're also going to be getting the time to live, which, I don't know, isn't that useful, but if you're ever analyzing a network, I don't know, maybe there's something weird about that. We'll get the protocol and, of course, the source address and the destination address to see pretty much what servers or what websites they are actually connecting to. Now again, all of this data that you're looking at that we're going to extract, this is just the header. Now an IP header basically comes before the IP payload or data, and it's pretty much, if you think of it like a package that you would just send through the mail, this would be on the label. But the actual data inside is inside the box, which is the good stuff. So this is pretty much information that precedes every IP payload, pretty much just to give information about it. So let's just go ahead and do version header length. All right. So the first thing we're going to do is we're just going to get information about the version and the header length. So remember, that's the very first byte. So if you rate data 0, that's going to give us that. But now what we actually need to do is this combined, it isn't really useful because this is actually broken up into version and header length. Now, if you guys are wondering how we can extract the version out of here, if you remember from my bitwise operator tutorials in Python 3, we can actually take this and bit shift it to the right by 4 bits. Now what that's going to do is it's pretty much going to shift this out, and we're going to be left with only the version. So 0000 and then the version. And if you guys don't have any idea what I'm talking about, go watch my bitwise operator tutorials, and I'll show you guys how to use bitwise operations It's actually not that hard. It just sounds weird. So version header length. What we're going to do is we're going to take that entire byte and bit shift it by 4 to the right. Now that's only going to leave us with a version number, so that's taken care of. Now to get the header length, what we can do is a little something that's kind of tricky. We can actually take the version header length and we can AND it by 15. And again, in that same tutorial, I talked to you guys about how to AND and what the bitwise AND operator means. Basically, you're going to compare 2 bytes and you're going to get the result when both of those bytes are 1. So if you multiply that by 4, this is going to give you the header length. Now if you guys are like, why do I even need the header length? Why are we doing this? You need the header length, in other words, the length of this entire data set, because the length of the header is used to determine where the data starts. Because right after the header ends, that's when your actual data begins. They're butted up right up against each other. So you pretty much read all the information from the header and then say after that, oh, that must be the data. So that's why we need all this crap right here. So now what we can do is we can actually start unpacking everything. So we're going to get the time to live, the IP protocol, the source, the target, and we'll just set this equal to struct unpack. Now this is kind of weird how this is packed together, so kind of pay attention here. All right, that was embarrassing. Okay, so the exclamation mark, that's just for saying that we want to make sure, you know, the byte order is correct. Now if you go 8x and then B, 2x, and then 4s. So this is the format that our data is going to be unpacked into, and now we need to say, well, where's the data? Well, the data is from the very beginning to 20 bytes. So it's 20 bytes long, and we can see that in this little diagram. All of your header information is 20 bytes long. So we're going to be giving it a chunk of binary and say, all right, extract it into these variables. Pretty cool, eh? Now the last thing that I'm going to want to do is this. I'm going to want to return a bunch of the information that we just got and also the actual data, the payload that's inside it. How do we do that? Well, let's just start returning crap. What did we figure out? We figured out the version already. We also figured out the header length, the time to live, and I can just copy this. We're also going to be returning the time to live, the protocol, and you know how before what we did is we formatted that MAC address properly? We actually need to do the same thing with the IP address. So later on we're going to be making a function called, I'll just name it like IPv4, and then we'll pass the source and target in there. So again, we already extracted the IP address, but now we just want to format it properly. And same thing with the target. Boom, roasted right in there. And the last piece of the puzzle that I want to return is just the payload. So how do we know where the actual data is? Not the header, we already took care of that, but the actual data, well, remember, it begins, which signifies the end of your header, so that's where you want to begin, and it just goes to the end. So just write header length is the beginning, and this will go to the end, which would just give you all the rest of it. So remember, an IP packet, the entire packet is broken up into a header, which is all this information, and the actual data. So that's what we're going to be doing, and whenever we unpack this, we just pass it in, it extracts all the cool information, and now we're ready to move on to the next video. And what we can actually do now is work on that formatting function. So let me just add a comment and say returns properly formatted IPv4 IPv $, all right, IPv4 address. Now, I'm sure you guys know how an IP address is formatted. It's basically like 123.456.whatever.whatever. I mean, you can't have 456, but it's pretty much three numbers with a dot separator. So what we can do is just call it, so define this, and we're going to pass it in the address. Remember, this address is the unformatted address. And now what we're just going to do is return join, and then we'll just map the DDR. All right. So we're basically taking all the chunks and we're going to map them to a string or convert them to a string. Now, once they're in proper string format, we can just join them with a dot in the middle. So you get something like 127.0.0.1. So these will be strings joined together with periods. Boom, roasted. There you go. So that is how you unpack an IPv4 packet and how you properly format an IPv4 address. And we are now ready to move on.